In logic, negation, also called logical complement, is an operation that takes a proposition P to another proposition not P, written AP, which is interpreted intuitively as being true when P is false and false when P is true. Negation is thus a unary logical connective. It may be applied as an operation on propositions, truth values, or semantic values more generally. In classical logic, negation is normally identified with the truth function that takes truth to falsity and vice versa. In intuitionistic logic, according to the Brouwer Heyting Kolmogorov interpretation, the negation of a proposition P is the proposition whose proofs are the refutations of P. Definition: no agreement exists as to the possibility of defining negation, as to its logical status, function, and meaning, as to its field of applicability, and as to the interpretation of the negative judgment. Classical negation is an operation on one logical value, typically the value of a proposition, that produces a value of true when its operand is false and a value of false when its operand is true. So, if statement A is true, then A would therefore be false. And conversely, if A is true, then A would be false. The truth table of AP is as follows. Classical negation can be defined in terms of other logical operations. For example, AP can be defined as P of F, where A is logical consequence and F is absolute falsehood. Conversely, one can define F as P and AP for any proposition P, where ampersand is logical conjunction. The idea here is that any contradiction is false. While these ideas work in both classical and intuitionistic logic, they do not work in Brazilian logic, where contradictions are not necessarily false. But in classical logic, we get a further identity. PAQ can be defined as APAQ, where A is logical disjunction, not P, or Q. Algebraically, classical negation corresponds to complementation in a Boolean algebra, and intuitionistic negation to pseudo-complementation in a Heyting algebra. These algebras provide a semantics for classical and intuitionistic logic respectively. Notation: the negation of a proposition P is notated in different ways in various contexts of discussion and fields of application. Among these variants are the following. In set theory, / is also used to indicate not member of U. /A is the set of all members of U that are not members of A. No matter how it is notated or symbolized, the negation AP/AP can be read as it is not the case that P, not that P, or usually more simply is not P. Properties: double negation. Within a system of classical logic, double negation, that is, the negation of a proposition P, is logically equivalent to P. Expressed in symbolic terms, APAP. In intuitionistic logic, a proposition implies its double negation but not conversely. This marks one important difference between classical and intuitionistic negation. Algebraically, classical negation is called an involution of period U. However, in intuitionistic logic we do have the equivalence of AP and AP. Moreover, in the propositional case, a sentence is classically provable if its double negation is intuitionistically provable. This result is known as Glavenko's theorem. Distributivity: De Morgan's laws provide a way of distributing negation over disjunction and conjunction A and. Linearity: in Boolean algebra, a linear function is one such that, if there exists AO, A1, and 0, one such that f, B1, Bn, equals AO for all B1, Bn 0, 1. Another way to express this is that each variable always makes a difference in the truth value of the operation or it never makes a difference. Negation is a linear logical operator. Self-dual: in Boolean algebra a self-dual function is one such that, f, A1, an, equals f, A1, an, for all A1, and 0, 1. Negation is a self-dual logical operator. Rules of inference: there are a number of equivalent ways to formulate rules for negation. One usual way to formulate classical negation in a natural deduction setting is to take as primitive rules of inference negation introduction, negation elimination, and double negation elimination. One obtains the rules for intuitionistic negation the same way but by excluding double negation elimination. Negation Introduction states that if an absurdity can be drawn as conclusion from P, then P must not be the case or refutable or etc. Negation Elimination states that anything follows from an absurdity. Sometimes negation elimination is formulated using a primitive absurdity sign *yen. In this case the rule says that from P and AP follows an absurdity. Together with double negation elimination one may infer our originally formulated rule, namely that anything follows from an absurdity. Typically the intuitionistic negation AP of P is defined as *yen. Then negation introduction and elimination are just special cases of implication introduction and elimination. In this case one must also add as a primitive rule ex falso quodlibet. Programming, as in mathematics, negation is used in computer science to construct logical statements. The exclamation mark signifies logical not in B, C, and languages with a C-inspired syntax such as C++, Java, JavaScript, Perl, and PHP. Not is the operator used in ALGOL 60, BASIC, and languages with an ALGOL or BASIC-inspired syntax such as Pascal, Ada, Eiffel and Seed 7. Some languages provide more than one operator for negation. A few languages like PLI and RAT for user for negation. Some modern computers and operating systems will display as on files encoded in ASCII. Most modern languages allow the above statement to be shortened from if to if, which allows sometimes, when the compiler interpreter is not able to optimize it, faster programs. In computer science there is also bitewise negation. This takes the value given and switches all the binary ones to zeros and zeros to ones. See bitewise operation. This is often used to create one's complement or tilde in C or C++ and two's complement as it basically creates the opposite or mathematical complement of the value. To get the absolute value of a given integer the following would work as the dash changes it from negative to positive. To demonstrate logical negation. Inverting the condition and reversing the outcomes produces code that is logically equivalent to the original code, that is will have identical results for any input. This convention occasionally surfaces in written speech, as computer-related slang for not. The phrase voting, for example, means not voting. Crypt semantics. In crypt semantics where the semantic values of formulae are sets of possible worlds, negation can be taken to mean set theoretic complementation. See also, logical conjunction, logical disjunction, not gate, bitewise not, ampheq, apotheosis, cyclic negation, double negative elimination, grammatical polarity, negation, negation as failure, square of opposition, binary opposition, references. Further reading, Gabay, Dov, and Wansing, Heinrich, eds. 1999. What is negation? Kluwer. Horn, L. 2001. A Natural History of Negation, University of Chicago Press. G. H. von Wright, 1953 €59, On the Logic of Negation, Commentations Physico-Mathematicae 22. Wansing, Heinrich, 2001, Negation, in Goebel, Lou, ed., The Blackwell Guide to Philosophical Logic, Blackwell. Marco Tetmanti, Rosa Minanti, Pasquale della Rosa, Andrea Fellini, Daniela Pirani, Stefano F. Cappa and Andrea Moro. Negation in the Brain, Modulating Action Representation, Neuroimage Volume 43, Issue 2, November 1, 2008, pages 358 to €367, http, dx.org Neuroimage. 2008.08.004/ External links, Haswinkel, Michiel, ed., Negation, Encyclopedia of Mathematics, Springer, ISBN A978-1-55608-010-4, not, on MathWorld.